Welcome back to the solutions manual. In this video, we will solve the problem 2-44 from RC Hibbeler Engineering Statics 14th edition. According to this problem, we have to determine the magnitude of the resultant force and its direction measured clockwise from the positive x-axis. So to solve this problem, first of all, we have to resolve the forces into their components. This 30 lb force has a single component directed along the positive x-axis, so we don't have to resolve it. For 40 lb force, we have a horizontal component and we have a vertical component. Also for this 91 lb force, we have a vertical component and the horizontal component. Let's label them. So for 40 lb force, we have to consider this triangle. So the vertical component of 40 lb force is 40 into the ratio of 4/5 and the horizontal component is 40 into the ratio of 3/5. For the 91 lb force, we have to consider this triangle, 5, 12 and 13 triangle. So the vertical component of this 91 lb force is 91 into the ratio of 12/13 and the horizontal component is 91 into 5/13. So far we have resolved the forces into their components. Now we can find the x and the y components of the resultant force. So for the x component of the resultant force, let's call this Frx. So Frx is equals to sum of the forces along x-axis. I am considering right hand side as positive. So we have this 30 lb force plus 40 into 3/5 plus the horizontal component of this 91 lb force. So 91 into 5/13. So upon simplification, Frx comes out to be 89 lbs. Now we have to do the same for the y component of the resultant force. So for Fry, we have to sum the components in the y-axis. I am considering up direction as positive. Vertical component of this 40 lb force. So 40 into 4/5 minus the vertical component of this 91 lb force. So 91 into 12/13. So upon simplification, Fry comes out to be negative 52 lbs. Now we are getting a negative answer. The negative answer means that the direction we had assumed earlier for Fry is incorrect. Earlier we had assumed Fry in the upward direction, but in actual it is acting in the downward direction. So Fry is 52 lbs in the downward direction. So these are the x and the y components of our resultant force. Now we have to find the magnitude of the resultant force. So for magnitude, we have to use the Pythagoras theorem. So it is the square root of Frx square plus Fry square. So it is square root of 89 square plus 52 square. So the magnitude of the resultant force comes out to be 103.1 lbs. So this is our first answer. Now we have to find the direction of the resultant force that has to be measured clockwise from the positive x-axis. So if I draw the resultant force, then it would look something like this. This is the x-axis and that's the y-axis. This is negative x-axis and that's the negative y-axis. So using the head to tail rule of vector addition, we have frx in the positive x-axis and fry in the negative y-axis. So this is frx and this is fry, and the resultant can be drawn from the tail of the first vector to the head of the last vector. Let's label them. So this is frx, this is fry, and this is the resultant force fr. And since we have to measure the direction clockwise from the positive x-axis, so basically we have to find this angle. Let's call this theta. So for theta, we can use the ratio of 10. So tan theta is equals to fry over frx, and we just have to use their magnitudes. So tan theta is equals to 52 upon 89. So theta is equals to tan inverse of 52 upon 89. So if we take the tan inverse of this value, then theta comes out to be 30.3 degrees. So this is our second answer. So this is it for this problem. I hope you would find this video helpful. If you do, please make sure to subscribe to this channel and also turn on the bell icon for the daily updates. And if you have any questions or any doubts in this resolution of forces, then feel free to ask in the comment section and I will try to answer them as soon as possible. Thank you.